So you learned the basics of writing unit tests. Now let's talk about unit testing Redux applications. Earlier I told you that a unit test can test a single or multiple objects together. So how we define a unit is entirely up to us. As long as we don't touch external resources like web services, we are still writing a unit test. Now, one way to unit test a Redux application is to test its individual building blocks in isolation. So we're going to write separate tests for action creators, reducers, middleware, and so on. We call these tests solitary or lonely tests because they test a single function in isolation. This is a poor way of unit testing Redux applications, and unfortunately, that's what most books and courses teach you. There are a couple of problems with these tests. The first problem is that quite often, these tests know too much about how we have structured our application, so they get coupled to the implementation. When we change the implementation, these tests break, and that opens a whole new can of worms. We don't know if there is a problem in our tests or in our application code, so we have to spend some time to identify the source of the problem and then fix the broken tests. The more solitary tests we have, the more time we have to spend on this. So these tests get in the way and slow us down. They kill our productivity. That's why a lot of people like John Smith hate unit testing. John argues that unit testing is a waste of time because rather than writing code to solve the actual problems and deliver value, we waste time writing and fixing broken tests. If you think like John, let me tell you something, my friend. The problem is not unit testing itself. It's how you practice it. Our unit tests should not test the implementation. They should test the behavior of our application. Let me give you a metaphor. Think of a microwave. Let's imagine we want to test the timer of a microwave. How do we test it? Well, we press the start button and look at the timer. We don't care how the timer is implemented internally. We don't care how the electric current goes around and how it gets modified by various transistors. These are implementation details that can change in the future. In the next model, we may have an electronic board that is faster and cheaper, and it will probably work differently. But our microwave should still behave the same way. When we press the start button, it should show the timer. So we should test the behavior, not the implementation. The reason solitary tests break often is because they know too much about the implementation. They know exactly what action creators, reducers, and middleware we have. The other problem with this type of test is that they don't really give us much confidence that our application actually works. They're not reliable. We can have thousands of solitary tests testing every individual building block, but our application may not work. I will show you a real example of this in the next lesson. So we spend a lot of time writing and fixing these tests for very little value, if any. So rather than testing individual building blocks or the implementation, we should test the behavior of our application. Forget about the UI for a second. What is a Redux application really? It's a store management engine with dispatch and action and the state changes. All the building blocks like action creators, reducers, and middleware are there to ensure that the state of the store changes properly. So to test a Redux application, we should test these building blocks together with dispatch and action and check the state of the store. What happens under the hood should be irrelevant to our tests. We call these tests social tests, tests that involve multiple functions or objects working together. Again, as long as we don't touch external resources, we are still writing unit tests that can execute very quickly. These social tests are less fragile because they know very little or nothing about the implementation. So they don't break as often. We spend less time writing and maintaining them, and they're more reliable. If they pass, we know that our application will work. They test our Redux applications like how we test a microwave. They test the behavior of our application, not its implementation. What happens internally is irrelevant to these tests. They don't care if one action creator calls another action creator. They don't care if we have middleware that magically catches an action and dispatches another action. They don't care what reducers we have and how we combine them. These are implementation details. So does it mean solitary tests are bad and we should never test a building block in isolation? Absolutely not. Solitary tests are great and they have their own uses. If the building block we want to test is complex enough, we should test it in isolation. The building blocks of Redux applications are often very simple. They don't have any logic. Our action creators simply return an object. Our reducers take some state and return the new state. They don't have any complex logic or algorithm. You hardly, if ever, see any if statements or loops in these building blocks. There is no logic. So what we need to test is the collaboration of these building blocks together. So that's all about solitary and social tests. Over the next 2 lessons, I'm going to show you these tests in action.